Welcome to Brain Vision.
Okay, for this question, we can apply the energy balance equation, which is E dot include E dot out, since we know the change over the internal energy, kinetic energy, and the potential energy is equal to 0. So if we expand it, we'll have m dot h1 is equal to m dot h2 plus q dot. M dot here is the mass flow rate for the water, and h1 is the initial enthalpy for the water, h2 is the final enthalpy for the water. Q dot here is the rate of heat transfer out of water. So if we do some arrangement here, we have Q dot is equal to m dot times h2 minus h1, and h2 minus h1 can be expressed as Cp times T2 minus T1. Cp is the specific heat for the water, and T2 is the final temperature for the water, and T1 is the initial temperature for the water. So if we do some arrangement here, we'll have Q dot is equal to m dot times Cp times T2 minus T1. So we know the mass flow rate is given as 4 pounds mass per second. And the specific heat for the water is 1 British thermal units per pound mass times degree Fahrenheit. We know the final temperature is 180 degree Fahrenheit, and initial temperature is 55 degree Fahrenheit. So now let's plug in back to the equation to determine the rate of heat transfer out of the water, which is equal to 4 pound mass per second, and then times 1 British thermal units per pound mass times degree Fahrenheit, and then times 180 degree Fahrenheit minus 55 degree Fahrenheit. And this will give us the rate of heat transfer out of the water is about 500 British thermal units per second. So now let's convert it to British thermal units per hour, which is 500 British thermal units over 1 over 3600 hour, since we know 1 hour has 3600 seconds. And this will give us the rate of heat transfer out of the system is about 1.8 times 10 to the power of 6 British thermal units per hour. And in the question, we know that the rate of heat transfer per feet length is given as 400 British thermal units per hour. So therefore, we can use the rate of heat transfer out of water divided by the rate of heat transfer per feet length to determine the length of the parabolic collector. Okay. So therefore, let's start it. So the length can be equal to 1.8 times 10 to the power of 6 British thermal units per hour divided by length. The rate of heat transfer per feet length, which is 400 British thermal units per hour, and then per feet length, which is times feet. And this will give us the length is about 4,500 feet. And this is the answer for this question.